our second video for the day. And in our second video, we're going to start teaching today's lesson. And we're not going to deal with coordinates. We're going to deal with different types of transformation geometry and basically your ability to recognize the type of transformation and the general nature of what they look like and how you work with them. Okay, so normally we have the so far summary, but at this point we're going to kind of have a look ahead summary. This is what we're going to be talking about over the next few minutes. A line reflection is a flip, and it produces a mirror image over a line that's in the middle between the shape and its image. A point reflection puts the point in the middle between the shape and its image. And again, we're going to do lots and lots of pictures of these things. This is just to get your mind set up, and then you might want to take a photograph of this particular slide for your phone because it'll help you recognize which is which. A translation slides the shape horizontally and or vertically, okay? So some of the key words you're seeing so far are like for reflections, you're dealing with flips. A translation is a slide. A rotation turns the shape about a specific point. It rotates it. So a rotation and turn are a good pair of words that mean each other. And lastly, a dilation grows or shrinks a shape, kind of like your eyes dilating, okay? All right. Now, let's talk line reflections first. Two key words to keep in mind with line reflections are a flip and a mirror image. And for the longest time, reflections have been used in art and photography. Honestly, most of these transformations have been used in art and photography. For example, there's one with a line reflection running right down almost the middle. It's slightly closer to the top, which, by the way, is generally speaking considered to be good standard photography technique. And another. Okay. So here's an example of a line reflection. We start with a shape called a pre-image. That's on the left. And the pre-image is reflected over the line, K. That's the line running right up and down the middle. And you create the image. Now, I want you to notice this word equal down here. This is extremely important when we get into coordinates tomorrow. It's important all the time, but it's how we're going to do reflections in coordinate geometry in our next lesson. But what you see is the distance from A to K, the line, is equal to the distance from K to A prime. And that's how we create the mirror image. If those distances were not equal, then it wouldn't look the same on both sides of the line. It wouldn't be as if it was flipped over. Notice the distance from B to K is the same as B prime to K, and C to K is the same as C prime to K. That's the key to understanding and doing a reflection, okay? The pre-image is the shape you begin with. The image is the shape that results. Here are two more to look at. Okay, we have a vertical line reflection first. Okay, you can see how those distances in blue, red, and green are the same about that line in the middle. And likewise, a horizontal reflection. The first one is that's a vertical line reflection. I don't know why they labeled it horizontal. It should be vertical. And the other one is a horizontal line reflection. They made a mistake, the people who made this graphic. Okay, very easy to remember the difference between horizontal and vertical. Horizontal goes across the horizon, and this line on the right looks like the horizon. The one on the left does not. Okay, bottom line is you flip it over the line, and the distances have to be the same from the green point to the line and from the line to the other green point, the blue point to the line and the line to the other blue point, which always messes with me because my hometown is Blue Point, and then the red to the line and the line to the red point. Okay. Here's another one. Lines don't need to be vertical or horizontal to flip over them. You can flip over any line. So therefore, you can reflect over any line. Now, do you see this notation here? The original triangle kind of to the left is triangle PQR, and the resulting triangle is triangle P prime. That's what we call it when you get this little markup here. P prime, Q prime, R prime. So anytime you see the primes in a diagram, you know that that's the image, and the other triangle that matches up with it is the pre-image. Here's a little bit of a proof, if you will, kind of a construction proof that shows you that these two distances are the same. If you wanted to find the line of reflection here, you could find the perpendicular bisector of the segment that connects E and E prime, or F and F prime. And when you find that, you have found the line that that you're reflecting over. Again, notice the prime notation, right? DEF, E prime, F prime, and down below is D prime. Now, I want to show you a little bit about what is and what is not a reflection. So if I take the red, it's almost like a 1960s Paisley symbol thing here, and I reflect it over the first line at the bottom, I get a reflection. The reason I can tell it's a reflection is it's a mirror image there. But if I went from the red one to the blue one, it's not a reflection. That's more of a slide. If I went from the green one to the blue one, now that is a reflection because it looks the same on both sides of the top line. Okay? So red to green is a reflection on the bottom line. Red to blue is not. Green to blue is a reflection on the top line. Okay? A couple of more instances. Line of reflection with a seal standing in front of a mirror. You can see how the distances are the same and the seal sits there in the mirror. Next, the line of reflection. This is a vertical line reflection. You're flipping over the vertical line, and you can see that the distances between C and C prime, D and D prime, B and B prime, A and A prime all match up. You can see how the darker quadrilateral on the left is called the pre-image, the lighter one on the right. They have reflection down there, but we would call it the image, okay? All points in the pre-image and all points on the reflection are the same distances from the line of reflection. That's important to understand, and we're really hammering it home with the image on the right, where you can see with the hash marks there that the distance from C to K, the line of reflection, is the same as the distance from K to C prime. And those distances are always perpendicular distances, okay? Now, one last one to do when we talk about line reflections, and this is a hint toward tomorrow. Tomorrow we're going to start talking about these lines of reflection on graph paper. And the reason is because you can count on graph paper. So look, if I count from this upper left-hand corner here, 1, 2, 3, 1, 2, 3. From the bottom, 1, 2, 3, 1, 2, 3. Notice all distances are perpendicular, 1 and 1. And that's a clue as to how we will do line reflections tomorrow on graph paper. And tomorrow we do all of these things on graph paper. Okay, so line reflections are done. Let's talk point reflections. Now, the first thing is about a point reflection is it looks the same upside down. So if you were, for instance, I have no idea why this says a B of spades. I think it's supposed to be a jack of spades. I don't think it's the king. The bottom line is if you spin that card upside down, you get the same exact image. If you spin a Z upside down, you get the same exact image, an S, or this particular figure, which looks like some kind of an atomic structure or a molecular structure, more to the point. They look identical upside down. So that's how you can recognize a point reflection. And it is, as the letter Z suggests here, it's a 180-degree rotation. That's what it is about flipping it upside down. Okay? You've turned it 180 degrees. So here's an example. Like before, we always made the distance between the point and the line you're reflecting over, and then the line you're reflecting over and the image equal. Here we do that with the center point, the point we're reflecting over. So from B to the center point has got to be matched from the center point to B prime. From A to the center point has to match from the center point to A prime. Okay? So that's a point reflection. This center point is the point about which or around which we are reflecting. So here's an image of some kind of shape. It reminds me a little bit of a musical note, but I don't know much about that. And you can see that with these pairs of points, the image and its pre-image, or the pre-image and its image, that they match up where the distance is, like let's take this long one here, is the same either side of that point in the middle. Okay, here's the short one. So that's what we see. All right. This is known in playing cards. This is known as the dead king. It's the only card in the deck where the king is killing himself. Again, if you flip that card upside down, you see the same exact card. Playing cards are like that, at least the picture cards. And if you ignore the little E and the little P, this figure, kind of like string art there, that figure is the same upside down and right side up. And that's really the key to recognizing a point reflection. Or it is also a way to recognize 180-degree rotation, because a point reflection and 180-degree rotation are the same thing. Here's the letter S. You can see how that is, it looks the same upside down, right? And the point of reflection there would be right in the middle here of this S. And then finally, this 1, 2, 3, it is a quadrilateral. No, 1, 2, 3, 4, 5. Yeah, pentagon, strange looking pentagon. But this pentagon on the right is reflected through the green point in the middle. And you can see how all the points and the pre-images and images pair up, and they are an equal distance away. Again, I'm hinting at what coordinate geometry would be like. But if you take this purple point up here where my cursor is and count to the green point, it's over 1 and down 5. So if I go down another 5 and over another 1, I get the purple point. Same thing here with this darker purple point. It's down 1, over 2, 4, 6, 8. So I go over another 8 and down another 1, and I get this darker purple point. So those are hints about what in the future point reflections will look like when we get to coordinate geometry in our next lesson. Okay, our last image of a examples of a rotation. Now, the red one to the green one, that's not a rotation. That's a slide. That's a translation. But if I go red to orange, now that's a spin. That's a 180-degree spin. That's a point reflection. And if I go orange to green, that's also a 180-degree turn or rotation, or 180 degrees is a point reflection. So we're reflecting through that black point to turn the orange into green. So red to orange, point reflection. Orange to green, point reflection. There also happen to be 180-degree rotations, which we will talk about in a little bit. But red to green, nope. Got nothing going on there in red to green. All right, next slide we will get into is the translation slide. But for now, let's stop this video.